Good morning, students. Last class we have discussed binary search and max and min algorithms. Okay, so now we go for the merge sort. So merge sort is a sorting technique that is used to sort the given elements in non-decreasing order. So merge sort is a sorting algorithm, a sorting technique that is used to sort the given elements in a non-decreasing order. So given a sequence of n elements a1, a2 and so on an, the general idea is split array elements into two sets, that is a of 1 to a of n by 2 and a of n by 2 plus 1 to a of n. Okay, so merge sort is a sorting technique that is used to sort the given elements in non-decreasing order. Okay, see, a sorting algorithm that has the nice property that is the worst case its complexity is big O of n log n. This algorithm is called as a merge sort. So in given a sequence of n elements, that is a of 1 and so on a of n, the general idea is to imagine then split into two sets, that is e of 1 and so on e of n by 2 and e of n by 2 plus 1 and so on e of n. Okay, and each set is individually sorted, that the resulting sorted technique are merged and produce a single sorted sequence of n elements. Okay, see, each set is individually sorted and the resulting sorted sequence are merged to produce a single sorted sequence of n elements. Okay, and divide and conquer strategy is the capable as splitting the elements into the two equal sized sets and combining the operations is merging of the two sorted sets into the merge sort. Okay, so merge sort is a sorting technique that is used to sort the given elements, okay, in non-decreasing order. When the given elements are number of elements, then we can a of 1 to a of n. Then general idea is to imagine that the split into the two different sets, that is a of 1 and so on a of n by 2 and a of n by 2 plus 1 and so on a of n, and each set is individually sorted and the resulting sorted sequence are merged to produce a single sorted sequence of n elements. It is called as a merge sort. Okay, see, algorithm for merging sort is, see, E of low colon high is a global array to be sorted if small of p is true, if there is only one element to sort. In this case the list is already sorted. If the given elements are small, if it is true only one element is to sort, in this case the list is already sorted. Okay, so here algorithm merge sort of low comma high, two parameters, one is the low and second one is the high. See here, if low less than high, then if there are more than one element, okay, low value high value, that is if low less than high, that is if low less than high, then if there are more than one element. Okay, see here, divide p into sub problem where we have to divide, when we have to divide if there are more than one element. See, divide p into sub problems and find where to split the set, that is mid equal to low plus high by 2, and solve the sub problems merge sort of low comma mid and merge sort of mid plus 1 comma high. So how to have divide low value, mid value is one of the part and mid plus 1 high is the second part. So in that way we can say merge sort of low comma mid and merge sort of mid plus 1 comma high. Then when it will be completed sorting, then we have to combine these two solutions, that is low, mid and high. So combine the solutions, merge of low comma mid comma high. Okay, see, algorithm merge sort of low comma high. If low less than high, then divide p into sub problems. How to divide? Then mid equal to low plus high by 2, and solve these subproblem, that is merge sort of low comma mid and merge sort of mid plus 1 comma high, and combine these solutions, merge of low comma mid comma high. Okay, now it is only for the merge sort. Okay, algorithm for merge sort. So merge sort of low mid, merge sort of mid plus 1 comma high. Then how to merge the low value and low comma mid comma high? We go for the next algorithm. See here. Algorithm merge of low comma mid comma high. See here. Algorithm merge sort. Algorithm merge of low comma mid comma high. Here you can see algorithm merge of low comma mid comma high. See, it is a global array containing two sorted and subset into low, mid and mid plus 1 high. The global is to merge these two sets into a single set residing, that is A and A of low high. That is the B of is an auxiliary global array. Okay. Now we can go for H equal to low, I equal to low, J equal to mid plus 1. Okay. Here H equal to low means we can assign the index value. Okay. H equal to low means we can assign the index value. Here I equal to low is the first value and J equal to mid plus 1 is the second mid value. Okay now. So H equal to low is the index, I equal to low is first value. Okay now. While H less than or equal to mid and J less than or equal to high. So we can compare to the index value to mid value and J to high mid plus 1 to high value. See, if E of H less than or equal to E of J, then B of I equal to E of H, then H equal to H plus 1. So, E of H equal to 1, E of H equal to low, that is the mid value less than or equal like index value, then less than or equal to E of J. Okay. Then in that way, B of I equal to, that is low equal to E of H, then H equal to H plus 1. The H value like index value will be incremented. Otherwise, B of I equal to E of J, then J equal to J plus 1. So J value incremented, that is mid plus 1. That is then when completed, then I equal to I plus 1. Then go for if H greater than mid for K equal to J to high, then B of I equal to E of K, then I equal to I plus 1. Else K equal to H to mid, then B of I equal to E of K, then I equal to I plus 1. For K equal to low, high do E of K equal to B of K. Okay now. So H equal to index, I equal to first value, J equal to mid plus 1. First we have to compare to the H less than or equal to and J less than or equal to. Then we go for the condition A of H is less than or equal to A of J. Then B of I equal to A of H and H incremented. Otherwise B of I equal to E of J, then J is incremented. Then I will be incremented. That is the next element. Then if H greater than mid, then K equal to J to high, then B of I equal to E of K, then I is incremented. Then K equal to H to mid, then B of I is equal to E of K, then I is incremented. Then if K is low to high, then do E of K equal to B of, that is the equal elements. Okay now, this is the algorithm for only merge. So algorithm merge of low comma mid, that is to merge the three values, that is a low value, mid value, high value. Whenever we have to split, then these are merging with the using of this algorithm. Okay, see here. So algorithm merge sort of low comma high, that if low less than high, divide to the sub problems. How to divide? Mid equal to low plus high by 2. Then merge sort of low comma mid and merge sort of mid plus 1 comma high. Then combine these solutions, merge low comma mid comma high. Then we can apply the algorithm of merge for this statement, that is merge of low comma mid comma high. So algorithm merge of low comma mid comma high. So here H equal to low, that is index, I equal to the first element and mid plus 1. So H less than or equal to, while H less than or equal to mid and J less than or equal to high, then A of H is less than or equal to A of J, then B of I equal to A of H, and H equal to H plus 1. Otherwise B of I equal to A of J, J equal to J plus 1. Then increment I equal to I plus 1. If H greater than mid, then K equal to J to high, then B of I equal to A of K and I equal to I plus 1. Then K equal to H to mid, B of I equal to A of K comma I equal to I plus 1. Whenever the K equal to low to high, then do A of K equal to B of K. So likewise, you have to match the low comma mid comma high values. Okay, so what is the merge sort? Merge sort is a sorting technique that will be used to sort the given elements in non-decreasing order. So how to perform the operations? We can using the divide and conquer strategy. If the given elements are high, then we can split into the different of parts. Okay, then we can apply the divide and conquer technique. How to divide? Then a of 1 to a of n by 2 and a of n by 2 plus 1 to a of n. Okay, and this strategy used to the splitting the elements into two equal sized sets and combining the operation is merging of the two sets into the one. So that is the merge of low comma mid comma high. For example, consider the array of 10 elements, that is a of 1 is to 10, that equal to 310, 285, 179, 652, 351, 423, 861, 254, 450, 520. So totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So algorithm, that is a 1 is to 10. So algorithm merge sort begins by splitting E of into two sub arrays. Each of the size is 5, that is equal to 1 is to 5 and 6 is to 10. So two splittings, that is the 1 is to 5 is the one part size of and 6 to 10 is the one part. First we go for the 1 is to 5. See, the elements in a of 1 is to 5 are then split into two sub arrays, that is mid equal to low plus high, that equal to 1 plus 5, that is 6 by 2, that equal to 3, that is 1 is to 3 and 4 is to 5. Okay, then also we go for the E of 1 is to 3, that equal to mid equal to 1 plus 3 by 2, that equal to 2, or split into two sub arrays size 2, that is E of 1 is to 2 and one is E of 3 is to 3. Then the two values of in A of 1 is to 2 are split to find time into one element sub arrays and how the matching begins. Okay, so first of all we get in the number of elements is 10, we can split into 1 is to 5 and 6 is to 10. Then 1 is to 5 are split into two sub arrays of 1 is to 3, 4 is to 5. Then 1 is to 3 sub into 1 is to 2, 3 is to 3. Now we can merge split into the 1 is to 2. So and now the merging is begins. See, so 310, 285, 179, 652, 351, 423 is likewise. Okay, this is the first one where the vertical bar indicates the boundaries of subarrays. Now the elements of A of 1 and A of 2 are merged into yield 285, 310. Then say these two are merged, then 285 and 310. Then E of 3 is merged with E of 1 is to 2. So E of 1 is to 2 is 285, 310 and 179. These are merged. Then it will be combined 179, 285, 310. So 179, 285, 310. Okay. Now next elements of E of 4 and E of 5 are merged. That is E of 4 is 652 and 351. These two are merged. That is 351, 652. And then E of 1 is to 3 and E of 4 is to 5. That is 179, 285, 310, 351, 652. Okay. Now repeated the recursive calls are invoked producing the following sub arrays, that is 6 to 10. Okay, so 423, 861, 252, 450 and 520. So elements of E of 6 and E of 7 are merged, that is 423, 861. Then E of 8 is merged with 6 is to 7, that is 254, 254, 423, 861. So E of 6 is to 7 is with merge of E of 8, that is 254, 423, 861. Okay. Next E of 9 and E of 10 are merged, and then E of 6 is to 8 and E of 9 is to 10, that is 254, 423, 450, 520, A61. Okay, Now sort with the result 179, 254, 285, 310, 351, 423, 450, 652, 861. So the sorted result is 179, 254, 285, 310, 351, 423, 450, 520, 652, 861. So these are the sorting result. Okay. See here. First, the given elements are 10. We have to split into 1:5 and 6:10. First, we have to construct the 1:5. Then 1:5 split into 1:3 and 4:5. Then 1:3 is split into 1:2, 3:3. Then we can mention 1:2 and 3. Then go for 4, 5. Okay. So here. Then it will be completed. Then go for the completed. Then go for the 6, 7 and 8 and 9, 10. Then sorted result is 179, 254, 285, 310, 351, 423, 450, 520, 652, 861. Okay. Next, if the time of merging operation proportional to n, then the computing time of merge sort is sorted by the recurrence relation. Then t of n equal to a, n equal to 1 is the a constant, and 2t of n by 2 plus cn equal to n is greater than 1, c is a constant. So how we can see, when n is a power of 2, then n equal to 2 power k, we can solve this equation by successive substitutions. That is, t of n equal to 2 into 2t of n by 4 plus cn by 2 plus cn, that is 4t of n by 4 plus 2 cn. Then t of n only, then we can substitute 4 of 2t n by 8 plus cn by 4 plus 2 cn and so on. 2 power k into t of 1 sec of n is equal to an plus cn into log n, that is t of n equal to big O of n log n. That is a constant value, then n log n is the high value, that is t of n equal to big O of n log n. Okay. Here we can use the substitution method. So already we have discussed in the divide and conquer strategy. So we can use the substitution method. We can identify the complexity of particular merge sort algorithm. That is t of n equal to big O of n log n. Okay, see here, t of n equal to a, that is the constant value. That is otherwise 2 into t of n by 2 plus cn, that is n is greater than 1, that is the c is a constant. So now we can construct tn of 2tn by 2 plus cn. We can use the substitution method. Then we have to assign to the t of n equal to big O of n log n. Okay. So what are the drawbacks of merge sort? So slower comparative to the other sort algorithms for smaller tasks. So number of times we have to comparing. Okay, that is slower comparative to the other sort algorithms for the smaller tasks. Merge sort algorithm requires additional memory space of big O of n for the temporary array. So temporary we can store the sum of the elements in that way. So merge sort algorithm requires additional memory space of big O of n for the temporary array, and it goes through the whole process even if the array is sorted. Okay, whenever the array is also sorted, the process we go through. So it goes through the whole process even if the array is sorted. Okay. See, now when n equal to 10, so here n equal to 6, we have to represent the sequence of recursive calls that the procedure is produced by the merge sort is as follows. The pair of values in each node, that the values of parameters of low and high. See here, 6, 5, 12, 10, 9, 1. Here only 6 elements. First 3, 6, 5, 12. Then next 3, 4, 5, 6, 10, 9, 1. And 6, 5, 2 is the first element is 6. The next two elements 5, 12, 6. If there is no matching, 6, 6. Then here 5, 12, 5, 12. And already it will measure, then 5, 12. Then go for the three elements are merged, 6, 5, 12, that is 5 comma 6 comma 12. This is the one of the recursive calling function. The sequence of recursive calls that produced by the merge sort is also follows and cheptam. Okay, here see 10 9 1, 10 is the 1 and 9 comma 1, so it was split into the 9 1, then these two are merged, 1 and 9, then these are the 1 9 10, then both are merging, then 5 6 12 and 1 9 10, that is 1 5 6 9 10 12. Likewise we have to construct the sequence of recursive calls. Okay, here likewise also we have to construct the merge sort. Okay, so merge sort is a sorting technique. We can use the divide and conquer. We can merge the sort the given elements in non-decreasing order. Here we can split the values, that is the a of 1 is to a of n by 2 and a of n by 2 plus 1 to a of n. Okay, this is one of the algorithm as a merge sorting. And go for the merge for low mid high, you can use this algorithm, h equal to low, I equal to j equal to mid plus 1. It is the index value, it is the first value. Okay, then consider these elements, we can split into the mid value, that equal to mid equal to low plus high by 2. Likewise we have to construct these type of situations, and we can construct the time complexity, that is equal to t of n equal to a, then n equal to 1 is a constant, and 2t of n by 2 plus c and n greater than or equal to c is a constant. Then here we can apply the substitution method. We can construct the t of n equal to big O of n log n. Okay, and what are the drawbacks? It is a slow compared to the other sort algorithms for the smaller talks, and merge sort algorithm requires additional memory space of big O of n for the temporary array, and it goes through the whole process if the array is sorted. And also we can go for the recursive call of the particular merge sort, also we can like that. Okay, so 6 5 12 10 9 1, there is a 6 5 12 and three elements, then single and 2, that 6 and 5 comma 12 mid plus 1 plus 3 by 2. Okay, 1 comma 2, and likewise so we can lastly 5 6 12 1 9 10, we can merge these elements 1 5 6 9 10 12. Okay, see the time complexity is big O of n log n. Merge sort, the average case or best case also big O of n log n. Okay, thank you.